All right, let's talk about quadratic equations. I know, they can seem a little intimidating, but trust me, once you have the right set of tools, there's something you can totally master. So today, we're going to build your complete toolkit and turn this into a topic you can tackle with real confidence.
Okay, let's jump right in with an example. You see an equation like x squared plus 5x equals 6. Now, you might just be looking for one way to get to the answer. But what if I told you there are a few different, really powerful methods? Knowing them all makes you a much more flexible and powerful problem solver. We're going to use this exact equation to test drive each method. But first, let's make sure we're all on the same page. What even is a quadratic equation? Well, the dead giveaway is that little x squared term. If the highest power of your variable is 2, you're looking at a quadratic. And here's a cool connection. These are the equations that, when you graph them, create those classic U-shaped curves called parabolas. So that's what we're dealing with today. All right, first tool out of the box, this is a method you've probably seen before. It's the classic approach, and when it works, it's often the fastest way to get an answer. I'm talking about factorizing. So let's walk through it with our example. Step 1 is absolutely critical for this method. You have to get everything onto one side of the equation so that it equals 0. So we'll subtract that 6 from both sides. Now for the fun part. It's kind of like a puzzle. We need to find two numbers that multiply to make our last number, -6, and add up to our middle number, +5. After a little thought, you land on +6 and -1. Perfect. That lets us rewrite the equation into two neat little brackets. And from there, for either one of those brackets to make the whole thing 0, we can solve them individually. So x could be -6 or x could be 1. Two answers. So why does that last step even work? Why can we just split the brackets up? Well, it's all because of this really simple but powerful idea called the zero product rule. Think about it. If you multiply two things together and the answer is 0, one of those things has to be 0, right? There's no other way. That's the entire logical leap that makes factorizing work as a method. Pretty neat. Okay, so factorizing is great. But let's be real, sometimes finding those two numbers is either super hard or just plain impossible. For those situations, we need a heavy-duty power tool, one that works every single time. And that is the quadratic formula. And here it is. Yeah, I know, it looks a little scary, but honestly, this formula is your best friend when you're stuck. It's a really, really good idea to just memorize this because in an exam, you can't always count on it being in a formula book. Now, before we just start plugging numbers in, we got to get our ducks in a row. We have to correctly identify our a, b, and c values from our equation, which again has to be in that equals 0 format. So a is the number in front of x squared, in our case that's just a 1, b is the number in front of x, which is 5, and c is a number all by itself at the end, which is -6. Don't forget that negative sign. And look what happens. We carefully substitute those values in. Then we just have to clean up what's under that square root sign. So 5 squared is 25, and -4 times 1 times -6 is a +24. So 25 plus 24 is 49. The square root of 49 is 7. That plus or minus symbol is what gives us our two answers. And what do you know? We get x equals 1 and x equals -6, the exact same solutions we got from factorizing. It works. Okay, now I'm going to let you in on a little secret, a clever shortcut that can save you a ton of time. You don't always have to jump to factorizing or the big formula. If you spot a certain kind of equation, there's a much quicker way. Look at an equation like this. You could multiply out the bracket, move the 5 over, and then use the quadratic formula, but wow, that's a lot of work. Here's the pro tip. If you see that the variable x only shows up in one place in the whole equation, you can just solve it directly. We can use inverse operations. Just square root both sides to undo to square, then add 1. It's so much faster. So always keep an eye out for the special case. All right, time to level up a little bit. Sometimes you'll come across an equation that doesn't look like a quadratic at all. But actually, it's just a quadratic wearing a very clever disguise. We're going to learn how to spot these pseudo-quadratics. Take a look at this one. Does that look like a quadratic to you? Probably not, right? There's no x squared term. But believe it or not, it is. We just need to use a little trick to reveal its true form. So here's the secret. Here's the pattern you're looking for. You have something, in this case, it's the square root of x. Then you have that thing squared. Well, the square root of x squared is just x. And finally, you have a plain old number. When you see that pattern, a term, its square, and a constant, you've found a quadratic in disguise. And here's how we unmask it. We just do a little substitution. Let's temporarily swap out that messy root x for a simple letter, like y. If y equals root x, then y squared must equal x. Now we rewrite the whole equation with y, and boom, it's just a simple quadratic that we can easily factorize. We get that y is 2 or 4. But wait, we're not done. The original question asked for x, not y, so we have to substitute back. If root x is 2, then x must be 4. And if root x is 4, x must be 16. Just brilliant. Now for what might be one of the most important habits to build, not just here, but in all of mathematics. I'm talking about checking your work. It's especially, and I mean especially critical, when you do one specific thing, squaring both sides of an equation. So to solve an equation like this, your first instinct is probably to square both sides to get rid of that pesky square root, right? And that's a good move. But here's the catch. When you do that and solve the resulting quadratic, you might find two answers, like x equals 1 and x equals 6. But are they both actually correct? Let's find out. We have to check by plugging our answers back into the original equation. Let's try x equals 1. The left side becomes the square root of 4, which is 2. The right side becomes 1 minus 3, which is negative 2. Uh-oh, 2 does not equal negative 2. This means x equals 1 is a false solution. It's an answer that we accidentally created along the way. Okay, now let's try our other answer, x equals 6. The left side becomes the square root of 9, which is 3, and the right side, 6 minus 3, is also 3. This one works perfectly. 3 equals 3. So the only real solution to this equation is x equals 6. So what is going on here? Why does this even happen? Well, think about it. If you take negative 2 and square it, you get 4. If you take positive 2 and square it, you also get 4. The act of squaring completely erases the original sign of the number. It loses that information. So when we squared both sides, we created an opening for a solution that didn't actually work in the original, more specific equation. And that's why you absolutely must check your answers anytime you use that move.
So there you have it. You've now got this awesome, complete toolkit. You know how to factorize, you've got the power of the formula, you know the shortcut to look for, and you can even spot those tricky quadratics in disguise. The real skill, the thing that comes with practice, is learning to look at a problem and know instantly which tool is the best one for the job. You are now equipped to unmask a whole range of problems that are secretly just quadratics. So the question I want to leave you with is this. What other disguises might you find? You'll see them with things like x to the power of 4 or even in trigonometry. Just keep an eye out for that core pattern, a thing, that thing squared, and a constant. Because now, you've got the tools to solve it. Thanks for watching.